What prehistoric ocean held the longest neck? But this ancient marine reptile defied typical reptilian forms. Meet the Elasmosaurus, a master of the Cretaceous seas. Its body was streamlined, built for efficient ocean travel. But the true marvel lies in its astonishing serpentine neck. It possessed up to 72 cervical vertebrae, an incredible number. This neck often dwarfed the entire length of its body. The neck could comprise half of the creature's total length. Contrastingly, the skull remained remarkably small and lightweight. These teeth were perfect for grasping slippery, fast-moving prey. Now that we understand X, let's explore why its function. It was not designed for immense, vertical lifting power. The body remained submerged and largely hidden from prey. Muscles anchored at the torso provided the primary power stroke. Only the head and neck moved rapidly, minimizing water disturbance. But this allowed for a strike radius far exceeding its body length. Its flexibility enabled ambush predation from unexpected angles. The Elasmosaurus inhabited shallow coastal waters during its existence. Its primary diet consisted of smaller, schooling marine life. It was a highly specialized pelagic predator, not a bottom feeder. Locomotion relied entirely on four powerful, paddle-like limbs. And these limbs provided sustained thrust, much like modern sea turtles. Or it was capable of long-distance migration across open waters. Its body structure relates closely to the Plesiosaurs group. The neck evolved as an extreme specialization within this lineage. Its skin likely offered little insulation against cooler depths. Breathing required raising the head far above the ocean surface. An evidence suggests Elasmosaurus may have gathered in social groups. They shared their world with colossal marine predators. In defending against such threats proved challenging for the long-necked reptile. Its neck provided a surprising defensive advantage, whipping outwards. Arresting required finding safe, shallow zones near the coast. The long neck likely served as a flotation aid when inactive. Internal structures allowed flexibility without sacrificing necessary rigidity. But each segment was uniquely adapted for precise articulation. But water resistance was a constant factor the Elasmosaurus managed. Its foreflippers were the primary drivers for propulsion. Swimming required constant, rhythmic energy expenditure from the limbs. That the neck remained the defining, yet energetically expensive, feature. A hunting was a delicate balance between visibility and reach. And a swift bite ensured the prey could not escape the curved teeth. Evidence suggests potential nesting on nearby sandy beaches. But hauling out would have been extremely difficult and slow. Now that we understand X, let's explore its extinction context. The entire marine reptile group faced profound environmental shifts. Global sea levels fluctuated dramatically during the late period. But changes in ocean chemistry impacted their food sources severely. The large body size often requires substantial, consistent caloric intake. For its specialized neck offered little advantage in a collapsing ecosystem. The ultimate environmental pressure proved insurmountable for these giants. We now find their story preserved in stone, beneath the earth. Paleontologists meticulously study these unique skeletal arrangements. A reconstruction bridges the gap between fossil evidence and living form. The limb structure reveals powerful adaptation for aquatic life only. The Elasmosaurus remains an icon of extreme evolutionary experimentation. It dominated its niche through unparalleled neck extension. Every bone tells a story of survival in a dynamic ocean. Its vision was crucial for spotting prey across those vast neck distances. The legacy of the long-necked swimmer endures in scientific understanding. Evolution found endless, incredible solutions for life in the water.